So we continue using modular arithmetic with these examples, but before we do that, let's go back to an earlier example for a minute where we had 21 plus 96 modulo 4. And what we did is we just went ahead and obviously we added this together and we said 117 modulo 4. And we determined that 117 modulo 4 has a remainder of 1. And what we did is we did 4 goes into 21 5 times with 1 left over, and 4 goes into 96 evenly, so that's going to give us a remainder of 0. And we had 1 plus 0, that's 1, and 1 mod 4 is 1. But we certainly don't have to do 21 and 96. You could break up 117 just about any way that you want to. Here's 58 plus 59. Mod 4, that's still 117, right? 4 goes into 58 14 times with 2 left over, and 4 goes into 59 14 times with 3 left over. And 2 plus 3, that's 5, and 5 mod 4 is 1. You could even try something like 100 plus 17, that's 117. Mod 4, 4 goes into 100 25 times evenly. That'll give us a 0 remainder, and 4 goes into 17 4 times with 1 left over. And that's also equal to 1. So you should do that. You should experiment with different versions of a number to help build your confidence in your understanding. Now, one of the beauties of breaking a dividend into parts is it can help us determine a remainder much more efficiently. And that's especially true for extremely large numbers. And often we don't even need the use of a calculator. So for example, for 57 to the 50th power mod 9, 57 to the 50th power means that we're taking 57 and multiplying it to itself 50 times. Now 57 to the 50th power, here's 57. Here is our caret key. We'll raise that to the 50th power. So this is an extremely large number. This is in scientific notation. This is times 10 to the 87th power. That means this decimal swings over 87 times. So it's very, very large. And if we were to divide that by 9, it's almost like it doesn't even look any different. It's still an exceedingly large number. But again, since 57 to the 50th power is 57 multiplied to itself 50 times, then if we did 57 modulus 9, 9 goes into 57 6 times with 3 left over, so this winds up equaling 3. So then we could write this as a congruence of 57 is congruent to 3 mod 9. So if 57 is congruent to 3 mod 9, then multiples of 57, which is what this power is, would be multiples of the same remainder. So we could say 57 to the 50th power is congruent to 3 to the 50th power mod 9. But even 3 to the 50th power gives us a quotient that is gigantic. Here it's 10 to the 23rd power, so that decimal is going to swing over 23 times. But I could rewrite this as 3 squared to the 25th power. Using our understanding of exponents, 2 times 25, that's 50, so we can write it like this. Mod 9. So we're just breaking it up like we did for that previous example. And 3 squared, that's 9. So this is 9 to the 25th power. So then I've got 9 going into 9, 9 going into 9, 9 going into 9. We do that 25 times, and 9 goes into 9 evenly. So 9 to the 25th power mod 9 will give us a remainder of 0. So 57 to the 50th power mod 9 is equal to 0. And we didn't even need our calculator. So if you recognize certain patterns, you can do some of this much more efficiently, and it's kind of fun to experiment with it. Here we have 196 mod 6. 196, if you recognize it, that's 14 squared. So we could say 14 squared mod 6, similar to the 21 plus 96 mod 4 that we were doing earlier. So 14 squared mod 6, how about if we do 14 mod 6? 6 goes into 14 2 times with 2 left over. Then I can say that 14 is congruent to 2 mod 6. If 14 is congruent to 2 mod 6, then 14 squared is congruent to 2 squared mod 6. And 2 squared is 4. So 196 mod 6 is 4. And we didn't even need to use our calculator. So for 6 here, we're just going to take a practical approach to this. It says determine negative 156 mod 11. I'm going to draw a number line here. And if you can imagine, here's negative 156 way down here. Let's just say here's 0 here. So the idea is 11's going to go in here so many times. So as 11 goes into 156, I wind up coming over 11. So then this is negative 145. We're at negative 145. Come over another 11. I'm now at negative 134. I come over another 11. I'm at negative 123. And I continue this over and over and over. Eventually I end up over here at negative 2. I then come over another 11. I end up at 9. So without using a calculator, without really doing any calculation other than bouncing along a number line here, I can say that negative 156 mod 11 is equal to 9. And there we have it.